All right, so there's different ways we can talk about the composition of something. So for example, I've got my car here, and car is made out of the car body. That's what we're going to call this. And then it's every car body, or every car has four wheels. And so if we have four wheels and one car body, is a car made up mostly of wheels? I think most of us would say no, right? So cars are mostly wheels, right? And the answer to that is probably no. And the reason that it's no is that a car body weighs a lot more than four tires, right? So even though there are four tires for every car, the tires don't make up most of the car, right? And the reason that we don't say it makes up most of the car is what we're talking about here is mass percent, right? How much of the mass does it make up? And so we can do the same thing with elements. So for example, our CH4, right? Every CH4 is made up out of one carbon and four hydrogens. So you might think, oh, that's mostly hydrogen. And by count, yes, it is mostly hydrogen, but is it mostly hydrogen by mass? And so what we're going to try to do here is calculate the mass percent. And the reason that calculating the mass percent is useful is because we have analytical techniques that can tell us the mass percent of unknowns. And so then we can compare that to knowns and we can identify what our unknown compound is. So mass percent is going to be for each element in the compound. So we're going to find a mass percent for carbon and a mass percent for hydrogen. And if we do it right, it should add up to 100% or at least very close, depending on how the rounding goes. So mass percent is equal to the mass of your component, whatever you're interested in. So in this case, it would be the carbon and then the hydrogen in separate calculations over the total mass. And then to make it a percentage, we just multiply it by 100%. So let's take a look at the different components, right? We've already taken a look at CH4. Hydrogen weighs 1.008 grams per mole. Carbon weighs 12.011 grams per mole, right? You can see that carbon weighs about 12 times as much as hydrogen. So that'll kind of give you a hint as to which one makes up the larger mass percent. And so then we can add those numbers up, multiply the hydrogen by 4, and we'll find CH4 weighs 16.043 grams per mole. And that's our total mass. So that's what's going to get plugged into this denominator here. And then we can calculate the mass percent for carbon and hydrogen separately, and they should add up to about 100%. And so that's where the mass of the component is going to go. So for the carbon side of things, we're going to take the mass of our carbon. So we only have one of them. And so that's 1 times 12.001 divided by the whole mass, which is at 16.043. Multiply by 100%, and we'll get 74.87%. So CH4 is 74.87% carbon by mass. And then we can do the same thing for hydrogen. Don't forget to multiply it by the number of hydrogens that there are. In this case, there's 4 of them. Divide by our total mass, multiply by 100%, and you get 25.13%, right? So while hydrogen makes up most of CH4 by count, right? There's 4 hydrogens per carbon. Carbon makes up most of CH4 by weight, right? Almost 75% carbon. And that's because a carbon atom weighs much more than a hydrogen atom, right? A carbon atom weighs about 12 AMU or 12 grams per mole, and while a hydrogen only weighs about 1 gram per mole. Once we figure out how to calculate the mass percentages in this next part, we're going to learn how that's useful for us.